So today we're going to cover the long division of polynomials. We'll also cover simplifying when we divide by a monomial. Tomorrow we're going to add in the synthetic division part. Okay? So to start with, when we're dividing by a monomial, all right, there are two primary ways of dividing polynomials, and the biggest difference, what you need to look at, is what are you dividing by? What is your divisor? So we're going to start with dividing by a monomial, which will be a fairly different process than if we're dividing by anything else. What is a monomial? One term. Okay? If we are dividing by one singular term, now that can be a pretty complex term with as many factors as we want, but it's still just one term. So there's no addition, no subtraction. Dividing by a monomial. Then the process is basically the reverse of when we were kind of adding and getting a common denominator. We take all the terms of the numerator and we split it into multiple fractions, all with a common denominator. The denominator that is already there. That is our common denominator. And then we go through and simplify each fraction. So when I want to divide this polynomial by 3a, which is a monomial, we can set up the division all over 3a. And so we're going to take each and every term of the numerator and write it under that singular denominator, or write it over, I should say. So our first numerator divided by 3a, our second term divided by 3a, and our third term divided by 3a. Now, if you take a second before we even go to solve, let me get rid of this part. Okay, I'll bring it back. In a second. No, I'll bring it back in a second. But I want you to look. I have addition and subtraction. What do we have to have in order to add fractions? Common denominator. Okay. And once we have that, what we're doing is we add and subtract the numerators, and then we just leave the denominator, right? That's what that is. So we just kind of undid that and worked backwards and split it apart so that we can do the division and then we can simplify. And again, this only works if we're dividing by a monomial. So we'll go through and we'll simplify each term. Negative 12a to the third over 3a.
Negative 4a squared.
Negative 4a squared. Okay? 36a divided by 3a. 12. 15 over 3a.
5 by a. 5 over a.
5. There's no denominator, there's no value in the numerator to simplify with the a. So the a just stays in the denominator. There's nothing else we can do. So that's our division. So in a sense, it's very much kind of the reverse of that adding that we were doing. Taking three rational expressions and kind of add them together over a common denominator. Now we're just kind of working backwards when we divide by that monomial. Let's write our three ratios. All right? What's the first ratio going to be? What's the first term?
10t power of 4 by 5.
Okay? Next one?
Minus 35t over 5 squared.
Last one?
Plus 1.
Now we'll get
5 squared.
All right? Simplify the first one. Good. Second one.
Minus 7 plus 1.
Okay? So simplify each term. Sometimes it'll simplify nice. Sometimes we'll have fractions left over. Simplify each term all over that same denominator. Okay? Monomials only. I cannot emphasize that enough. Monomials only. Now, when we are dividing by something that's not a monomial, we're going to mirror the standard long division algorithm for dividing two numbers. So here's an example of our traditional long division, okay, with just integers. And this is the process of saying, okay, let's take 7,256 and divide it by 43. So we set up our dividend inside this little bracket and then our divisor on the outside. And we ask ourselves, and we start with that first digit. We say, can 43 go into 7? No. So then we need to move to the next placeholder. We need to go to the next digit and say, okay, well, can 43 go into 72?
Yes.
Yeah. How many times?
One time.
Once. So that's that first step of divide. Well, then we need to figure out, okay, well, it goes in, but doesn't go in evenly. So we need to figure out, well, how much is left over? What's the extra? So we multiply and subtract to figure out the extra. We do 1 times 43, and then we subtract, and we get 29. Okay? So we have 29 left over. Well, can 43 go into 29? No. So then we continue the process, and we have to now look at the next place value over. Well, that's the bring down part. We got to bring down the 5. Well, can 43 go into 295? Yeah. How many times? 6. Well, you got it right there, right? And so we repeat that process of seeing how much it goes in, figure out that extra, bring down the next place value, and then go through that over and over and over until we get to a point where there's nothing left to bring down, and our divisor cannot go into whatever we have there. Okay? So that's that process. And then we look at our answer and say, okay, well, my final solution will be my quotient. Okay? That's my answer up at the top, 168. That's my quotient. Plus the remainder. Okay? What was my remainder? 32. So plus 32 over the divisor. My divisor is what we're dividing by. And that's how we get a mixed number. It's the quotient plus the remainder divided by the divisor. And that's how we get that. We're going to do a very, very similar process with our polynomials. And it's going to be that kind of 4-step process. Divide, multiply, subtract, bring down, repeat. Over and over and over until we get to the point where there's nothing to bring down and I can't divide it. Sometimes we'll get a remainder, sometimes we won't. And there'll be some stuff that we expand on that. So we're going to go through that process. Alright? The only difference, the big key difference, is that we're not looking at how many times does 7x plus 3 go into my first place value. We're only looking at the first term on each. We're only looking at the first term. So we're going to start with 28x squared divided by 7x. 4x. So that's the first part of my quotient. So we're going to put it up here. Now, you'll see later on why it's really, really important, but you're going to want to keep all of your like terms in order. Okay? Keep them all lined up nice and neat. Okay? So our first step was to do the division. Now we're going to go to step 2, which is multiply. Okay? Just like before, whatever we had up here got multiplied by our divisor to get each additional line. Right here and right here. Okay? We're multiplying by that to figure out how much we have left over. We're going to do the same thing here. So we're going to multiply 4x by the entire thing. So what is 4x times 7x?
28 squared.
And then 4x times 3 plus 12x. So we did 4x times the divisor. 7x plus 3. Okay? 4x times 7x plus 3. Next step is to subtract.
Why 4x?
Because that's what we had in the division. When we did the first part of our quotient, every time we get a new value in our quotient, the subtract step will be that times our divisor. So whatever we have up here, multiplied by this, every time. Okay? So now we're going to subtract. Next step is to subtract. If one step is going to mess you up more than any other, it's going to be this step. You need to pay really subtraction and the signs of your values. Okay? This will be the part that messes you up more. So 28x squared divided by 20, or so minus 28x squared. 0. That should be 0. If it's anything other than 0, you mess something up. Go back and fix it. Okay?
It's gonna be always 0.
That first one will. If it's not, then you didn't do it.
Like
Every. Okay? Now the second one could be anything. Okay?
11. No, it's
Minus
negative.
35.
Negative.
11. Wait, why is it negative?
Just plus it.
Because it's negative.
Yeah, but where is the negative come from?
We are subtracting.
You're right.
Negative 23 minus 12.
Oh, never mind.
No. Because it's like terms.
So it's like we're subtracting.
We are subtracting this entire thing.
If you know it's negative, why are you putting plus?
Because
It's gonna be
that's
more.
plus. This could end up being negative. And then I have to subtract the negative. This sign is based off of this multiplication.
So, what is it?
What's 28 minus 28?
Okay, but oh, okay, then minus it.
So, sir, you have a minus for the 28.
What is 4x times 7x? That's why it's positive. What's 4x times 3? That's why it's positive. And then we subtract. It doesn't have to be positive. Sometimes, depending on what this sign is or what this is, it may be negative. So we're going to match those signs up and then subtract. That way it's consistent, and then you don't have to, well, is it positive, is it negative, do I add, subtract it? You multiply it, you get the answer, then you subtract it. Okay? So, negative 23x minus 12x, negative 35x. So we subtracted 28x squared and negative 23x minus that product that we got from the previous step.
So that's minus
5.
That's the step 4. Step 4 is to bring down. We bring down the negative 15, and then we repeat the process. Okay? Bring down the negative 15, and then we repeat the process, and now we do division.
What do we multiply by?
Well, we have to do the division first. Negative 35x divided by 7x. Negative 5.
And that's always been the same. And that's always been this.
When we, the subtraction step, that first subtraction should always be 0.
As you move down.
As we move down. So it should always be 0. In red or blue? So after the subtraction, then we bring down the next term, and then we start back at divide. Negative 35x divided by 7x. So whenever we're doing the division step, it's the first term of whatever line we're on divided by the first term of our divisor. So every time we do a division, it's going to be by 7x. So we started with the first term of our dividend divided by 7x. The first term after our subtraction divided by 7x. If I had more terms after that, it's always by 7x, by 7x, 7x. Whatever that first term is, you're dividing by that over and over and over and over until we run out.
Where does the 3 come in place?
When we multiply. It's the only time you use it. You're only using the 3 when you multiply. So we divide, we get negative 5. Step 2 is to multiply again. So now it's going to be negative 5 times that whole thing. That's where the 3 comes back in. It's the only time you deal with the 3. Negative 5 times 7x. Minus 35x. Negative 5 times 3. Minus 15. And then we subtract. That way, that equals 0. Negative 15 minus negative 15 also equals 0. So what's my remainder? What's my remainder? What do I have left over? Nothing. So there's no remainder. The next one we do will have a remainder. But here we have no remainder. There's nothing left over. It all canceled out. We have no remainder. So our answer is just the quotient. What's my quotient?
4x minus 5.
There you go. 4x minus 5. That's the quotient. Right? So we repeat that process for no matter how long our dividend is. We just do it over and over and over until we can't divide anymore. There's nothing left to bring down. Let's do it again. Yes. Take a picture. Gentlemen, do you need to leave? Okay, who should you ask questions to? Okay. I don't want you guys disrupting their learning. So if it happens again, you're gone. Understood? Ask your question. So it's the multiply. We did negative 5 times 7x plus 3. And then we subtracted those last 2 steps. What's step 1?
2x.
2x divided by.
Divide, step 1.
You have to write that down.
No, but it's helpful to give yourself a checklist.
Divide, multiply, subtract.
And then, okay, so divide first. What is 4x squared divided by 2x? 2x. Oh, real quick. Back here. Real quick. Notice how everything's in line. All my squared terms, all my linear terms, all my constants. Okay? Organization is really important because especially as these get longer, it's very, very easy to get confused about what goes where and what's being added and what's being subtracted, what's positive or negative. You want to keep it as clean as you can and keep everything in line. Okay? It'll pay off later, I promise. You want to keep everything in line. Alright? Now, what we're doing. Step 2. Multiply. 2x by the divisor.
So 4x squared again.
4x squared. And what else? Plus 14x. Step 3. Subtract. 4x squared minus 4x squared. 0. Negative 6x minus 14x. Minus 20x. And step 4. Okay. Now what?
Now you go back.
Back to divide. We're going to divide again. What are we dividing?
2x.
Negative 20x divided by 2x. What does that give me? Next step. So, negative 10 times 2x.
Minus 7.
Okay. Next step. Subtract. So, negative 20x minus negative 20x. 0. 8 minus negative 70. Careful with that subtraction. 8 minus negative 70 is the same as 8 plus. You get 78. Can I divide 78 by 2x and not end up with a fraction? Then we're done. That's our remainder. That's what's left over.
So what's the last line?
Right here?
No, after that we bring down the 8.
Brought down the 8.
Yeah,
Then we went back up to divide. And we start that over again.
Sir, it's not a fraction. Then you don't.
If we were to divide 78 by 2x, I'm left with 39 over. I'm left with a rational expression. Don't do that. We don't want to do this. So that's our remainder.
But then do we still put 78?
Yep, that's going to be the remainder over the quotient, or over the divisor.
How do we write that? 78 over 2.
Quotient plus remainder over divisor. Quotient plus remainder over divisor. The next slide, for time purposes, we're going to skip it. It's more of the same. It's fine. I'd rather get to some other ones further down the line. So.
But when we multiply it,
We multiplied, we leave the 2x here because we already did multiplication with that. So we'll do multiplication with each step down the line. As we add another term, then we do multiplication with that. We don't want to do it twice. We did negative 10 times 2x and by 7. That's how we got to 70 here. Okay? All right. So skip to this one. All right. So we have to set it up ourselves. What goes on the outside?
1 minus 2.
What goes on the inside? That's the expression that goes in there, but not in that order.
Y squared minus 5y minus y squared.
It needs to be in standard form. Order of descending powers. Start with your highest degree and work your way down. So we have y squared minus 5y plus 6. All right, so step 1. Divide. What am I dividing? Good. Y squared divided by y gives me y. Put it up here. Step 2. Multiply. Y times y. And then y times negative 2.
Minus 2y.
But then you got it.
Yeah, don't skip ahead. There's going to be too much going on to skip ahead. Okay. All right. Step 3. Subtract. Y squared minus y squared. Negative 5y minus negative 2y. Negative 3y. Step 4. Add the 6. Repeat. Divide. Negative 3y divided by y. The 3. We multiply. Negative 3 times y. Negative 3 times negative 2. Subtract. Those cancel. What's our remainder? There's no remainder, so our answer is just the quotient y minus 3. Okay, and there's a special thing when we divide and there's no remainder. We'll cover that a little bit more tomorrow. It's definitely something worth noting. All right, what's going on the outside? What goes on the inside? Say again?
No, 2x.
It's the same process, but we have an extra degree. We're 1 degree higher, so we're just going to have one more step, one more rotation through the process. It's still going to be divide, multiply, subtract, bring down. What are we dividing first?
7x.
Okay. Multiply.
7x cubed plus 6x squared.
Okay.
It's 28.
Subtracting, you don't get rid of the variables. You only cancel them out if you're dividing or subtracting. Okay? Bring down. Alright, now what? What's getting divided? Negative 12x squared divided by x. Negative 12x. Then we multiply. And then negative 12x times 4.
Minus 48x.
Track. Those cancel. Because it's a negative 12x
Plus 50x.
times. Yes.
Is it always gonna be like the first one is gonna be?
If this doesn't cancel, we did something wrong. That
So
first
it-
one needs to
at
cancel.
both. At both.
If this doesn't cancel, if this doesn't cancel, then we did something wrong. We need to make sure that whatever the next line is, we're going down in power. So this was the third power, this is the second power, this is the first power. We need to be going down. If that doesn't cancel, then we mess something. Okay? All right?
Why negative 48?
Negative 12x times positive 4, negative 48. All right? What's after the 50x? Bring down the 1. So we just had to do it one extra time. Now what? 50x divided by x. Do it again. Oh, we get 50 here. And we multiply. 50x plus 200. So when we subtract, what's our remainder?
0. 201. Negative 201.
50 times 4.
Negative 201.
Negative 201. So our quotient plus the remainder over the divisor. Quotient plus remainder over divisor. Pay attention on your assignment because sometimes it'll have like this as a blank. And sometimes it'll have like this as a blank and it'll say plus with a blank over the divisor. So if you see the plus sign, just remember that that needs to be negative. Does that make sense? Okay.
Now for if it asks about
Joe, you can either write it minus 201 because it's a negative 201, right? Or as plus negative. Either one's fine. Alright. I'll go back. Alright, what's going to go on the outside? What's going to go on the inside?
27x.
Okay, now.
We divided 27x cubed.
What's that going to give me?
9x squared.
So that first division gives me 9x squared. Well, where do I put it?
On top of 27.
So where?
Over the 27.
Over the plus.
They're not like terms. I can't put it over the 8 or the x third.
It's not.
We can still do it.
We can still do it.
After the 8.
No.
The 8 fact. Before the 8.
Put it.
Between the plus.
We will put it before the 8. And we will put it after the 27.
The plus. That's what I'm saying.
That's 0.
We have to.
Yes.
Ain't no way.
Because you need something to subtract that 9x squared from.
Where did that 9x come from?
That?
Yeah.
From 27x to the third divided by 3x.
Oh, right.
We need something to subtract that from. So we have to put in placeholder zeros. So whenever you're doing your division, if you notice that you're missing some of your exponents between your highest to your lowest, put in placeholder zeros. 0x squared. It still equals 0. It didn't change anything. Plus 0 doesn't do anything. But it gives us something to subtract. So we can put the 9x squared here. We can multiply now. Here and here. So we get 27x to the third. Okay. Plus 9x squared.
No, 18.
18x squared. Thank you. Sorry. 18.
9x squared multiplied by 2 equals 18x squared.
Okay. So now we have something to subtract it from. So the first one cancels, as it should, and then 0x squared minus 18x squared. Minus 19, or 18x squared. Then we bring down the placeholder.
Now we divide.
So we divide again. Then we multiply. Then we subtract 0 minus negative 12x. 12x. Bring down the 8.
Answer is
Minus 6x.
So, do we have a remainder?
No.
Nope. So it divides nice and evenly, leaving us with 9x squared minus 6x plus 4. Oh yeah, that's why they call it long division.
for no reason.
No, there's a reason.
What's the reason?
To divide.
Where are we going to do this in the real world upstairs? Where are we going to use this on?
Nowhere.
Exactly.
Unless you're an engineer, chemistry, business, finance.
You don't use long division for business.
Yeah, but you'll need this for calculus. So.
There is my
Remainder. It is just the quotient.
We don't write Divison.
Correct. Because it would be 0 over something, which is just 0. So we don't need it.
No need.
Yeah.
So in that case, just the.
It was just what was up top. Okay. I'll put it. We're gonna run out of time. I don't want to finish, but I'll let you get whatever you need after. Okay. I'll wait to erase it. All right. What goes on the outside?
X squared
X
minus
squared
2.
What goes on the inside?
The rest. No, let's do X. Yeah, that's true. That's true.
We had the 5th power, we had the 3rd power, but we didn't have the 4th power. So we need a placeholder for that 4th power. This example is really important because you're going to see the importance of having your work neat and ordered and nice and pretty. Okay. Now, we did a placeholder 0 for x to the 4th. On the divisor, we don't need a placeholder 0. Okay? We don't need a placeholder 0 for the divisor. We only need it for our dividend. So you can leave x squared minus 2 the way it is. Alright? So, don't blink. You're going to miss this. So we'll do division. Step 1. 3x to the 5th divided by x squared is 3x to the 3rd. I'm skipping over the 5th, the 4th, and going straight to the 3rd. Well, it's the 3rd. We want to keep it in order. I mean, right. So we want to keep it in order. So we put it over the 3rd. We do our multiplication. 3x to the 3rd times x squared. 3x to the 3rd times negative 2. That should be 6. I'll be okay.
What about the 4? That to the power of 4?
There's nothing there.
Where is the point?
This time it was.
About the
Well,
place.
why do we even need that space?
What about the placeholder?
We need the space holder to start because we don't know whether or not we're going to need it. Okay? If this wasn't squared, I would 100% need it. Okay? If I had a trinomial and it was x squared plus x minus 2, I would definitely need it. Sometimes you won't need it, but put it in case you need it.
So until we actually need it, we're just gonna act like it's not there.
Yep. Because if I have 0 minus nothing, nothing, right? It doesn't get in the way of anything.
Okay.
So now we can still do our subtraction. That will cancel.
Yeah.
That's still going to be 0. 0 minus 0 is 0. And then we get our 5x to the 3rd. Now this time, actually I'm just going to bring this down to the start. Okay, we bring down, we repeat the process. Okay? 5x to the 3rd divided by x squared. 5x. We skipped over that squared spot because I didn't get anything squared. Okay? So then when we multiply, we get 5x to the 3rd. 5x times negative 2, nothing here. Negative 10x. So I need to bring this negative 12 down as well.
Why don't we do the square again?
It's still there, because now we have something.
You will not be taking down there.
We will be taking it down,
Wait, why don't we use it?
because we didn't need it.
No, why?
But it's still there. Guys, seriously, unless you just want to hang out with me for the next 20 minutes. 5x to the 3rd minus 5x to the 3rd. That cancels. 4x squared minus nothing. 4x squared. Negative 12 minus negative 10. Negative 2x. And then we would just continue one more time. Alright? We bring down the negative 8. So we have it. We divide. We get plus 4. Okay? Plus 4. We multiply. 4x squared minus 8. So then when we subtract, that goes away. That cancels out. I'm still left with negative 2x. That is our remainder. Because if I try to divide again, I'm still left with a fraction. Okay? Alright. You are released unless you have questions.
Why?